All right, with our workshop project set up, let's get started with an introduction to GitLab and how we are positioned specifically in the telco industry. First, I'd like to give a bit of background about the idea behind GitLab. Around 15 years ago, we had many different technologies for email, weather, music, phone services, etc. But they were spread across all these different interfaces. For example, you would have a Walkman for your music, a physical calendar on your wall, and a Nikon camera for photography. Then the smartphone came along and changed all of this. It directly integrated everything into a single intuitive device. All of a sudden, you could make phone calls, take pictures, listen to music, or surf the internet through one single interface. Now, today's software delivery landscape is very similar to what we saw 15 years ago with the various services. At the bottom, we can see the different functionalities one typically needs to have a fully functional DevSecOps lifecycle. And above, we can see the common point solution for these stages. For example, Jenkins for CI/CD, Snyk for security topics, or Jira for project management. Now, why is this a problem? This often undermines transformation as it requires a lot of additional support for creating and maintaining integration and orchestration. Measuring transformation becomes difficult across all these different tools, and additionally, collaboration also becomes difficult as there isn't a single platform to collaborate on, but it requires switching between different tools and different contexts. It also increases costs and maintenance overhead. As we can see, these difficulties increase over time. Although increasing the number of tools or the number of projects on their own only slightly increases the complexity, adding more tools while we also grow the number of projects exponentially increases the complexity around managing your environments. That's why GitLab is the ideal solution to address this, as it offers a single AI-powered DevSecOps platform. This means it's a single tool for project planning, source code management, continuous integration, infrastructure configuration, incident monitoring, application security, and much more. This helps drastically reduce the complexity, allowing us to create better, more secure software faster. So, how does this specifically benefit us as the mobile operator Tanuki Telco? Well, a platform like GitLab can support a modern Tier 1 communication service provider by enhancing efficiency, reliability, and security across various aspects of their operations. For example, GitLab can support with network infrastructure management by offering infrastructure as code, managing network configurations, deploying updates, and automating infrastructure changes using tools like Terraform and Ansible. Or GitLab can support with version control for configurations to help tracking and managing changes to network configurations and ensuring traceability while reducing errors. It, of course, also helps with software development and deployment. For example, through CI/CD pipelines, which allow us to automate the build, test, and deployment of network management software, customer-facing applications, and internal tools, as well as through release management, where we can manage complex release cycles with GitLab environments and release management features. Additionally, GitLab can help us with improving collaboration and workflow management within our organization. This is done through a unified platform approach, providing a single platform for development, operations, and networking engineers to collaborate seamlessly. GitLab also offers issue tracking and boards, allowing us to manage tasks, projects, and cross-functional activities. Finally, GitLab is considered a DevSecOps platform, meaning it can, of course, support with security and compliance. It offers built-in security scanning for code, dependencies, and container images to identify and mitigate vulnerabilities. Shift-left security allows you to also integrate security best practices early in the development lifecycle, ensuring that security is part of the CI/CD pipeline. You can enforce security policies and compliance requirements throughout the development and deployment processes. And finally, compliance tracking allows you to ensure compliance with industry standards and regulations through automated compliance checks and audit trails. For example, one way how GitLab can help is with network function virtualization. For a mobile operator, managing network functions through virtualization is critical. GitLab can automate the lifecycle management of virtual network functions from development and testing to deployment and monitoring, ensuring that updates and new functions are delivered rapidly and reliably. So as we can see, GitLab can support a modern Tier 1 communication service provider by offering a comprehensive platform that enhances collaboration, automates critical processes, ensures security and compliance, and provides robust tools for monitoring and incident management. By leveraging GitLab, mobile operators can improve operational efficiency, accelerate service delivery, and maintain high standards of quality and reliability in their network and services. So after this short introduction, I want to go over the agenda with you. First, we'll talk about how you can plan your work with GitLab. We'll take a look at issues, issue boards, merge requests, and GitLab Duo Chat. Next, we'll cover some CI/CD topics like how to set up your pipelines, how to use templates and components, and how the Duo root cause analysis can help you troubleshoot your pipeline runs. And then we'll be taking a look at enforcing compliance. Here, we will set up a security policy and a code owners file and see what GitLab offers to manage the vulnerabilities that were found in the code. Lastly, we will finish up with release operations, where we learn how to create and manage releases with GitLab. Each of these sections will also contain a hands-on part, and we'll have a break in the middle as well. So let's take a look by how we can do agile planning with GitLab, which is one of the first stages in the software development lifecycle. First of all, organizing your work. With GitLab, you can define work items, both on the project level, for example, to make specific adjustments to the implementation of an application, all the way up to group level, where you can define top-level strategic initiatives across the entire organization. By using issues within projects, you can specify individual pieces of work that need to be done. Multi-level epics on a group level help you to collect thematically similar issues and epics in one location. Of course, we also need to track the progress of implementing these work items. This can be done, for example, using iterations, which track smaller increments like 2-week sprints, or with milestones, which track efforts across larger timeframes like a few months. Additionally, there are ways to visualize this, for example, by using roadmaps. Now, when it comes to actually implementing these changes, one would leverage a Git repo, which is at the heart of a GitLab project. For each change, you would generate a merge request, which allows collaboration and visualization of progress towards implementing the desired changes. The CI/CD pipelines allow us to automatically build, test, and stage the changes we make with our merge requests. Once the changes have been made, code reviews are done where developer peers review and comment on the proposed changes. Finally, once everything looks good, approvals are given within the merge request, signaling a sign-off on the code changes. To help visualize this workflow, let's take a look at this diagram. Here we can see a simpler alternative to the Git flow, which we call the GitLab flow. GitLab flow assumes your main branch is your default branch. The idea is to practice feature branching while at the same time keeping a separate production branch. Whenever your main branch is ready to be deployed, you merge into the production branch and release that. We recommend for DevOps teams to follow this GitLab flow process while using GitLab capabilities within a concurrent development lifecycle. This process assumes that developers work in a separate branch called a feature branch that is merged to the default branch once work for an issue is finished and validated. Additional branches off of the default branch can be used for staging, production, and maintenance of stable releases. So let's go over a simple workflow example. The first step is that a team member creates an issue inside GitLab or Jira, for example, for a new feature that should be implemented. A developer then creates a feature branch and a merge request to start working on the implementation of that issue. The next step is that the developer creates commits and pushes their commits to the feature branch. The CI pipeline and security scans run, and a GitLab review app is spun up. Another team member then reviews the code and shares any questions or comments. After the code review is complete and the changes are approved, the release team member merges the merge request and the features deployed to the production environment. This workflow is similar for other tasks that are not necessarily related to the implementation of a new feature, such as infrastructure as code changes, for example. Before we jump into our first hands-on section, let's briefly talk about labels. They are a key part of GitLab, allowing you to categorize, filter, and search epic issues and merge requests. You can also set up boards directly in GitLab based on those labels. We'll also see that in the hands-on section. And there's no need to replicate labels for each project, as you can define them on a group level as well as the project level. So with that, let's go ahead and start our first hands-on part. I will close the presentation, and you should be able to see my GitLab. So on the left-hand side, I will do the changes, and then on the right-hand side, we will have the instructions. So to see the instructions, you need to go inside your Tanuki Racing Telco workshop project, then go to courses, use cases, Telco, and you can see the instructions for the four hands-on sections that we have planned today. So let's open up the first one. I will slowly go through each of the steps. You can follow along, and then at the end, you will have 5 minutes to catch up or look up anything that was unclear for you. And if anything comes up during the hands-on section, again, feel free to reach out over the Zoom Q&A feature. All right, so let's get started. The first workshop, or the first hands-on part, is about planning development with GitLab project management tools. We will take a look at labels, issues, milestones. We will also create our own board and try out GitLab Duo Chat. So the first step is to create our labels. For that, we will go into our Tanuki Racing Telco workshop project, and then go to Manage Labels. You can see on the top right, there is the New Label button. And the first label we want to create is called P1. We can write a description. It's optional. You can also leave it empty and then choose a color. Let's just choose orange for now. And then we will also create a second label, which is called P2. I will choose another color for that and create the label. Great. So here at the bottom, you can see that we've already created 2 labels. Next, we want to create 3 more labels. And these are actually scope labels. So they have those double marks here. So that tells you that this is a scope label. And what this means is that all of those scope labels are mutually exclusive. That way you can visualize workflows within GitLab. So an issue, epic, or merge request can either have one of those labels. If you assign workflow planning and then assign workflow review, the workflow planning label will be removed, but we will also see that in action later. I will also give that a color and then create the 2 remaining labels. And lastly, workflow work in progress. All right. As you can see, we've created the 5 labels here at the bottom. That was already all we had to do for step 1. So let's move on to step 2, which is creating a new issue board. For that, we want to go to Plan Issue Boards. Right now, we have a default issue board that is called Development. So if we click on the menu here, we can create a new board. And the new board should be called Team Scope Board. We can leave the 2 check marks checked so that we will have an open list and a closed list. And then click Create Board. All right, now we are in the Team Scope board. So let's create a new list. Here we want to actually use our scope labels that we just created. So the first value will be workflow planning. Let's add this to the board, and then a new one, which is workflow work in progress. And then lastly, we have workflow review. So this is how our board now looks. We can easily visualize the flow that an issue will take. So from open to planning to work in progress to review, and then lastly to close. So once we create issues and assign labels to them, they will appear in this board. Next, we want to create a milestone. So under issue boards, we can click on milestones and then create a new milestone. This milestone should be called first release milestone. As a start date, we can select today. And then due date can be 1 week from now, which would be May 1st. We can leave the description empty just for demonstration purposes, and then create milestone. Click on create milestone. That shows us the first milestone. Now let's go back to the milestones overview and create another milestone. So again, click on new milestone at the top right. This one will be called second release milestone. The start date will be 1 week from now, so once the other milestone has ended. And the due date will be the week after, which would be May 8th. Again, we can leave the description empty for this, and then click on Create Milestone. Great, so now we have 2 milestones. We see the first release milestone, which is open. So this is starting today. And then we have the second release milestone, which is upcoming because it hasn't started yet. What if we hadn't known where to find our milestones, or we wanted to learn more about the milestone customization options? We can use GitLab Duo chat to ask these questions and do even more. So on the top right, you can click on GitLab Duo chat. This opens a new window to ask questions to Duo chat. So we want to ask GitLab Duo, what features does GitLab have to help me while I plan out my work? Let's paste it in here and then click send. All right, it's already starting to generate the answer. So it tells me GitLab offers several features to help you plan your work effectively. We have milestones, iterations, epics, issues, work items, and tasks. And it gives you a little more context about each of these. And then in the end, it also gives you sources, which could be links to our documentation, for example, in case you would like to learn more. For the rest of the workshop, you can use GitLab Duo to ask questions that may come up during the hands-on session. You can even ask it coding questions as well in case you get stuck. All right, so the next step is creating our issues. We will go to issues. It's also under plan, so plan issues. And then click on new issue at the top. The first issue we want to call is, or we want to create is called planning our work. In the description, we can copy and paste the description here. So it says, create 3 separate issues for setting up CI/CD, securing our application, and planning a release. You can assign the issue to yourself and assign the first release milestone. You can also add a weight to it. Let's say it has a weight of 2, and then select a due date, which is 1 week from now, because that's also when our milestone will end. And with that, we can create our first issue. So here you can see it. Of course, right now it's a rather short issue. They can be much longer with a much longer description as well. But that's basically how an issue looks and how you create one. So now let's create the 3 more issues. So again, go back to the issues through the breadcrumbs on the top here, and then click on New Issue. The next one will be set up GitLab CI/CD. Now, what we want to do next is we want to ensure that we are on plain text editing. So you can change here. This would be rich text editing, and then you can click on switch to plain text editing. And when we do that, another GitLab Duo feature will appear. So you can click on the Tanuki icon and then select Generate Issue Description. This will open a prompt window where you can enter a prompt from which an issue description will be generated. This is actually super handy and saves a lot of time. So let's enter, for this issue, we want to enable GitLab CI/CD for our project. Of course, this is a rather short prompt. It could be much longer with much more detail. That way it will also be more tailored to your use case or your requirements. So let's click on submit and wait until the issue description is generated. Great, so it generated an issue description saying enable GitLab CI/CD integration. It has a description, some tasks, an expected outcome, and some additional notes. And at the bottom, there's always a disclaimer that this description was generated using AI. So now we can add it to our first release milestone as well and set the due date to next week. And then add the workflow planning label. Here under labels, select workflow planning and click apply. That looks good. So with that, we can create the issue. Nice. That's already our second issue that we've created. Let's go back through the breadcrumbs at the top and create another issue. So the next one is called securing our application. Again, we will make sure that we are in plain text editing and click on the GitLab Duo icon to generate a new issue description. So here for this issue, we want to secure that, and then click on submit. Great. So now we have our issue description for our issue. Again, we have a description, some tasks, an expected outcome, and some additional notes. And at the bottom, we have our disclaimer again. The same with as we did with the previous issue. We want to add the workflow planning label and select our first release milestone and also select a due date. The rest you can fill out as you like. I'm just going to leave it empty for now and click on create issue again. And then for the last issue, let's go back to the issues overview, click on new issue. And as a title, we enter planning our release. By now, we already know the process. Click on GitLab Duo and generate the issue description. For this issue, we want to plan our release. And click on submit. All right. So here again, we can add the workflow label, workflow planning. We can add the milestone and a due date. And that's it. And with that, we have completed step 5. We have created 4 new issues, planning our work, set up GitLab CI/CD, securing our application, and planning our release. And these will also be the steps we will go through during the different hands-on parts throughout the workshop. So to see the results in the issue board, we now go back to plan and then issue boards. And then make sure that you select the team scoped board, which we created previously. And you can see that for the 3 issues where are already assigned the workflow planning label, they already appear in the correct list for workflow planning, and all the other ones appear in the open list. So now we can take the planning our work issue and drag and drop it, for example, into the planning list. So that means we've started planning this issue or planning the work on the issue. And as you can see, this automatically added the correct label to the issue. If you now say, all right, we want to start working on that issue, we can drag it and drop it to workflow work in progress. Now, if we take a look, might take a while, we can also just refresh the page and then take a look. Now it has the work in progress label. And then lastly, if we want to, if we have completed the work on the issue, we can move it into closed. And then also after a while, let's refresh again. And take a look, the issue has been closed and the corresponding label has been removed. So that's how you can track your work with issue boards, similar to as you would with any other Kanban board, for example. Another thing you can do in issue boards is you can set work in progress limits. So if you go to the gear icon on the top of a list, and then on edit, you can define a maximum number of either items or weights that can be inside this list. So that's also something you can use to plan your next sprint, for example. Okay, so let's move on to step 7, which is create a merge request. Let's start by moving the issue related to setting up CI/CD to work in progress. So setup GitLab CI/CD is now work in progress because we started working on it. We are now ready to work on the issue. So let's go on the issue and then scroll down to create merge request. Here, it will automatically create a default name for our feature branch. You can change it or just leave it as it is, and then click on create merge request. We can uncheck this mark as draft, and then also provide a description if we want to. It already references the issue that this merge request is based on. And then we can assign ourselves. It already has the first release milestone since the issue had the first release milestone, and it already has the same label as the issue that this merge request is based on. So then we can click on create merge request. All right, so all future work regarding setting up GitLab CI/CD can be tracked in this merge request, and other people can see what you've been up to and also do code reviews through the merge request. So this is a great tool for transparency and also collaboration. And then lastly, in step 8, we can take another look at GitLab Duo Chat. So for now, we've covered a small subset of GitLab's planning features. For example, we haven't talked about epics. So what if you wanted to know more about how to create and use epics in GitLab? What you can do is you can paste this in GitLab Duo Chat and then wait until it generates. 1 second, I have to remove my bar. Now, and create this. Let's quickly wait until it generates an answer. And here we have it, how to create an epic in GitLab. We have some prerequisites. We have how to set up the epic, and then all the epic details. And then last step is creating the epic. And then again, it references the source as well. So that's a great way to learn more about GitLab's features. All right, so that concludes the first hands-on session. Let me get back to the slides. As mentioned before, I will give you 5 minutes to catch up and complete the hands-on parts, and I'll be back at 45. So 2:45. See you in 5 minutes. Welcome back, everyone. I hope everyone was able to complete the first set of tasks for the Handson lab. Before we start with the next topic, just let's have another quick poll. to get you all engaged again and see that you're back. Could someone start the second poll, please? Great. So it says, where are you on your DevOps journey? We have a few answers coming in already. All right. It seems like a lot of you are just starting and are in the discovery phase, which is super exciting to see. I hope this workshop will help you a lot to get started with GitLab. Some of you are also using CI, so continuous integration. A few of you are also already using GitLab security features and testing on a per commit basis. You are using CD, continuous delivery. But it seems like not many are actually capturing and analyzing metrics in GitLab. All right, so thank you so much for participating. Let's end the poll here and then get back to our workshop. So in the next section, we'll take a closer look at CI/CD pipelines. First of all, let's talk about why one would want to implement CI/CD with GitLab. There are generally two aspects that allow you to create a full DevSecOps process. First of all, reusability. With templates, you can easily reuse various elements of the CI/CD pipeline, allowing you to expedite the DevSecOps processes. GitLab also supports flexibility by letting you customize your pipeline directly with YAML. With the GitLab API, it's also possible to automate these processes, resulting in even greater efficiency. So let's first take a closer look at templates. Templates are a great way to share and consume CI/CD capabilities amongst teams within your organization. They also offer a great way for GitLab to share different capabilities with its users, for example, the various security scanners, some of which we will also use later. The great thing is that templates are just YAML files, similar to one would use to define pipelines within a project. They are easily included in a pipeline by simply referencing them in the include statement of a project pipeline. They get included in your pipeline based on stages or any specific applicable rules. Some of you might have also heard of CI/CD components. They are similar to templates, but they offer some key differences. They are treated like a real app with releases and versioning. It's also easier to make them more dynamic by leveraging input parameters, which can be passed to the component. Testing of a component is also significantly easier, and you can easily discover components as they reside within the components catalog. Next, let's briefly discuss runners, which is where the jobs of your pipeline actually run. They can be executed in various ways, for example, using Shell, SSH, Docker, or Kubernetes. Runners work by polling GitLab instances for CI jobs and are highly customizable as you can tag specific jobs to run on specific runners. No matter how long a job runs, they should typically be picked up within 5 seconds. For those of you on AWS or GCP, you can even benefit from the auto-scaling capabilities, allowing you to always have the correct amount of runners online to fit your needs. Finally, runners are also suitable for security zoning. After learning some of the key concepts of GitLab CI/CD, let's take a look at the second hands-on section. So again, let me close the slides and go back to GitLab. We want to go back to our Telco group and open the second Handson lab. So this one will be focused on the foundation of DevSecOps. We will be taking a look at basic pipelines. We will run our first pipeline and then setting up components and also templates to use security scanners inside our pipeline. And then lastly, use some advanced CI/CD features to make our pipeline run more efficiently. So to get started, let's take another look at GitLab Duo Chat, as I want to show you some of the more features it gives you. So first of all, you can also see that here's some example questions that might be relevant in the context where you currently are. So for example, you can ask what changes were requested by the reviewer. So you just click on the bullet point there, and it will automatically be pasted into the chat. And now GitLab Duo is looking for an answer. Let's quickly wait. As this merge request currently doesn't contain any changes, it doesn't make a lot of sense, but just for demonstration purposes, this is what you would get. Another thing you can do is use different kinds of commands. For example, you can use reset to clear the context. Now we can have a fresh chat window to start with. And also you can use clear, as you can see here, to delete all previous conversations. Now let's go over to step number 2, which is basic pipelines. Now that we have our merge request all set up, we are going to start working on our CI/CD pipeline. To do that, we could either use the web IDE to write the GitLab CI YAML file, or we can go into the pipeline editor, and that's also what we are going to do now. So let's go to build and then pipeline editor. You can see we now have, we currently have a default pipeline in here, and now we want to change this. So first, we want to make sure that we are working on our feature branch that we created with the merge request. I think mine was called setup GitLab CI/CD. So let's change from the main branch to our feature branch. In the next step, we have on the right-hand side, we have this starting pipeline. So we can just use it as it is and paste it inside our pipeline editor. So we remove all of this and then add our YAML configuration just so that we have a starting point. As you can see, our pipeline currently has 2 stages, the build stage and the test stage. We have one job called build that runs in the build stage, and we have one job called test that runs in the test stage. The pipeline editor also provides us with different tools to help us as we write our pipelines. So you can see the different tabs at the top here. First, let's go and take a look at the Visualize tab. So this will actually visualize your pipeline. I mean, for now, we just have the 2 jobs, so that looks quite simple, but this might come in quite handy as our pipelines get more and more complex. Another helpful tool is Validate. So once you click on Validate Pipeline, it will actually simulate a Git push event and check if everything runs successfully. So that's, again, also very helpful when you're writing your own pipelines. And lastly, the full configuration tab that shows you what is actually being executed once the pipeline runs. So once we add templates and components, this is also super handy as a single source of truth that shows you what will be executed in a pipeline. But we will see that later as well. And then go back to edit, add a commit message. I'm just going to leave the default one here. Make sure you're still on your feature branch and then click on commit changes. Committing our changes has automatically triggered a new pipeline. So let's navigate to build pipelines to see our new pipeline run. Let's quickly wait until the new pipeline shows up. Here it is. So we can also go inside and we see that the build job is currently running. Maybe while we wait, also an interesting fact about this pipeline, you see that only the build job is running and the test job doesn't get executed. To find out why, let's take another look at the pipeline editor and take a closer look at, let's go back to our feature branch and take a closer look at the test job. Here we have actually defined a rule that says this job should only run if the commit branch is the default branch. As we are currently committing to a feature branch, this job doesn't get executed. And another interesting thing is the needs keyword here. So with the needs keyword, you can specify dependencies so that jobs should never run until another job has completed. The usual execution order is that one stage is executed after the other one, and all the jobs in one stage are executed in parallel. What you can do is specify this needs keyword with empty brackets. So this says that the test job doesn't need any other job to be completed for it to run. And what this does is it executes the test job right when the pipeline is created. Of course, only if we commit to the default branch, which is not the case in our case. So that's just some useful information to keep in mind here to see why we currently only run the build job. Now let's go back to our pipeline. And we see that the build job has failed. So let's click inside. We get this very long job log, which we now would have to analyze and try to find the error while this pipeline is failing. What we can do is use GitLab do root cause analysis. So at the very bottom, you will find the troubleshoot button. And when we click on this, GitLab do will open and provide us with a root cause analysis of why the pipeline is failing. So let's wait until this is generated. So it says the job failed during the Docker image push step with the error message denied access forbidden. This indicates a permission issue when trying to push the built Docker image to the GitLab container registry. It also gives us a sequence of events, an example fix, or multiple examples for fixes. So we can either update the CI/CD variables or permissions. We can configure proper registry permissions or use CI registry image variable. We can also check the deploy token. And then at the bottom, it says the most likely solution is to modify the image variable to point to a registry path where the CI job has write permissions, typically within the same project's registry namespace. So now we know that this is actually an authentication issue. And the instructions on the right-hand side also give us a solution, which is similar to what GitLab Duo provides here. So we need to add some form of authentication when we log into Docker. Next, we can just go ahead and copy the correct build job that is on the right-hand side here and go back to our pipeline editor. Again, let's ensure that you're still on your feature branch or change to your feature branch if you're not. And then replace the build job with the fix. Okay, so now we can commit our changes. While the pipeline is running, I will move on to step number 4, which is using a component. So other teams at our company will soon be adopting GitLab CI/CD solutions as well. So we want to pave the way by creating a component they can easily use to build their software. As part of this workshop, we've already created a component for you to speed up the process a little. So the CI/CD components have a very similar functionality in GitLab as templates, with the biggest difference being the CI/CD component catalog and the ability to take input variables. To check the CI/CD catalog, you can still, inside your pipeline editor, just click on the CI/CD catalog button. This will actually open a new window with the CI/CD catalog. Here you can see some components that have been created and released by GitLab, and also some other components that were community contributions. So feel free to take a look around and browse the catalog. There might always be some components that are useful for your pipelines. So it's a great tool that you can use. In our case, we want to use the Telco workshop component. If you want to know more about how to create components and how to release them, feel free to take a look at the documentation, or of course, you can also ask the GitLab Duo chat about it. So here is our Telco workshop component. You see it currently has version 1.0.0. You can also see when it was released and by whom. And if we click inside, we also get more details, how this component can be included in your pipeline and what inputs it has. And also in the instructions on the right-hand side, you can see that there's a link to the component file. So we can also click on that one and we see how the component looks inside. So how the YAML code is defined. We can see that the component has one input. It has a default variable, which is Telco work, a default value, which is Telco workshop, and a description for the input variable. And then it has one job in the build stage. And this basically does the same as our current build job. So we will be able to replace our current build job with this component. So let's head back to the instructions. And then go back to our pipeline, which should have completed by now. Let's take a look. Yes, so now the build was successful. So let's get back to the pipeline editor. Again, make sure you're on your feature branch. And let's use this component. Again, the instructions provide you a code snippet that you can use to include the component in your pipeline definition file. Let's just add it here. Make sure that the formatting is correct. And we can also remove our build job as the component basically does the same. Before we test our component, let's also add some security templates to our CI file. So in the step 5, we are going to add some security scanners, rules, and speed up the pipeline with caching. First, we'll add some scanners, which will run in the test stage. We will use templates for that. You can again see the code snippet here. It's very easy to include a scanner through a template. Just one line of code. So let's first copy those scanners. I'm not copying the includes keyword because we already have include here, and we can just add it to the already existing include statement. So with that, we have included container scanning, dependency scanning, fast, secret detection, and infrastructure as code scanning. And one other thing we want to do is we want to add a variable. So with this variable, we will actually use GitLab Advanced SAST. Per default, we are running our normal SAST scanner, but in our case, we want to use Advanced SAST. So we can just add this variable as well, set it to true. It's false per default. So we will set it to true to use GitLab Advanced SAST. And you can just add it to the existing variable section. Now, when we head over to the full configuration tab, it looks already very different because now we actually also have included the code from our component and our 5 different templates that we've included. So now the file got a lot longer, and we notice that the code that will be executed will be a lot more than what can be originally seen on here. Another thing that comes in handy once you use templates and components is this tree at the top. So by clicking here, you can actually get this tree to see which files are included in your pipeline definition file. So the GitLab CI YAML is the file that we are working in. And then we have one file for the component. And we have 5 additional template YAML files. We can also modify how the scanner in a template will be executed. And we will do this by overriding the code. So for example, in our case, we don't want our container scanning to run every single time we make a commit. We only want it to run against main. So that way we will just override the current template configuration with a snippet that is provided in step 5 here. So let's go over here and paste it. Again, make sure that the formatting is correct. So now it says the container scanning should only run if the commit ref name is called main, and otherwise it should never run. So that's also a way how you can customize your components. Lastly, we also want to speed up our whole pipeline using caching. We can just store the generated Ruby files instead of recreating them every pipeline run. So let's copy the snippet that we can find under 6 and add some caching. I will just add it here. That looks good. All right. So under 7, you can find the final pipeline definition file, how it should look after we've added the component, the templates, caching, and all the other little tweaks we've just done. So if you've gotten lost at any stage, just go to step number 7 and you will find the complete file. If you still followed along, you can also go ahead now and compare your version to the file you can find here. So, so far, everything looks good. One thing we can do, we can add the stages we can see on the right-hand side as well. We can add them here. And the other things should be included in my file as well. All right, so let's commit these changes. Again, once I click commit, the pipeline will start running. And this time, also all the security scans will run that we've just included. Of course, with the exception of container scanning, because we said we just wanted to run against main branch, and currently we are committing to the feature branch. But we can also take a look at the pipeline. So we have our build job and then a bunch of test jobs as well, which is dependency scanning, a few SAS scanners, and secret detection. Our test job is not running because we are committing to a feature branch, and container scanning is also not running, so keep that in mind. And then next we can take a look at our merge request. So we go to code merge request and open our merge request. All right. So while the pipeline is running, I would suggest that we take a 10 minutes break. You can use that time to catch up with the content that we've gone through today until now, or just use the time to recharge a bit, and we'll be back at 20 past 3. So actually it's an 11 minutes break. We'll be back at 20 past. So you have some time to catch up with the content and recharge. And then after the break, we'll take a look at the pipeline again and see how our merge request looks once the pipeline ran through. So I will start this timer. And I'll see you in 10 minutes or 11 minutes at 20 past. All right, welcome back, everyone. I hope you had a good break and you were able to complete the previous hands-on assignment. Now, before we continue with the slides, let's take a quick look at our pipeline that should have run through by now. Here, everything looks good. We can also get more details. So we see that the build job ran successfully and also all of the test jobs ran. So all of that looks good. So then we can go ahead and merge our merge request. Let's go back to code, merge requests. Can also see that now in the merge request, we get some more details of the security scans. So license compliance detected 5 licenses for the source branch only, and security scanning detected at least 39 new potential vulnerabilities. So now let's just merge and get back to the slides. So next, we'd like to cover how to enforce compliance within GitLab. Here you can see that the potential cost of remediating security vulnerabilities gets higher the closer to production the vulnerability gets. And this is only the cost for remediation. The impact to your company or brand can be catastrophic if a production vulnerability is exploited and your services or customer data become compromised. In the past 5 years, we've seen telecommunication regulators in every country set forward more rigid technical security requirements that operators must comply to avoid any potential risk to critical infrastructure. GitLab comes ready with many capabilities to take the pain out of improving your security posture. Here you can see a comprehensive list of GitLab security and compliance capabilities. Let's focus on pre-built scanning, which aims to find security vulnerabilities early on in the software development lifecycle. Secrets detection, SAST, and infrastructure as code scanning are key mechanisms to improve your security posture. You can also add your own capabilities to GitLab CI pipelines. For example, we've seen customers implement syntax verification or parameter checking. Much of what telco companies are deploying these days are microservice-based cloud-native applications that are designed for scalability. GitLab has native dependency and container scanning capabilities. The more robust your CI/CD checks are, the faster and safer you can accelerate your path to production. It's also worth noting that in the age of AI, having more safety nets via CI/CD will be crucial to successful adoption of this generative technology. Now, let's take a look at the overarching capabilities. GitLab is fundamentally designed to reduce friction on workflows and has comprehensive vulnerability management. Additionally, GitLab security policy enforcement and approval mechanisms can help ensure compliance and reduce risk. Here is an expanded list of our policy management capabilities. GitLab offers several capabilities to define roles and permissions and control access throughout the platform. Other capabilities, such as protected branches and merge request approvals, control that only approved and tested code gets into production. Security policies and compliance frameworks allow for robust governance. You can enforce the execution of specific security scanners through security policies and attach those policies to compliance frameworks. Thanks to the GitLab platform approach, our single data source allows great insights and auditing capabilities. It is no longer required to correlate the logs between multiple point solutions. Code changes can be linked to issues and releases, giving you control and traceability of the change. GitLab comes with a host of reporting capabilities that allows you to leverage this valuable data. Now, let's get hands-on again and explore how we can set up policies and enforce them to prevent unwanted changes happening to your main source code branches. So let's head back to GitLab and open the third hands-on lab. So let's go back to Telco and then open enforcing compliance. So during this hands-on session, we will take a look at approval policies, code owners, and then how this looks in the end when you apply it. And also, we want to take a closer look at the security dashboard and the vulnerability report. So first of all, step 1 is setting up our approval policy. As it stands, we currently have a secret detection job included in our pipeline that will alert us if any secrets are detected in the code base when it runs. However, that doesn't mean that it will block the current code from being merged. To do this, we will need to create a secret detection policy to specifically block these merges. To prevent this from ever happening again in the future, we can set up a new policy to run on all future merge requests. For our use case, leaked tokens are easy mistakes that can lead to massive problems, so we will create a quick policy to stop that. So next up, we will go under Secure, and then Policies, and then click on New Policy. Here you can see all the security policies that GitLab currently offers. We have merge request approval policies, scan execution policies, pipeline execution policies, and vulnerability management policies. For our purpose today, we will create a merge request approval policy. So we will select that. We can add a name. So in this policy, we want to enforce secret detection. The description is optional. The policy should be enabled. And then for the rule, we can select a security scan. Another option would be a license scan, but in our case, we want security scan. You can choose the scanner. So right now, all of the scanners are selected with clear all. None of them are selected anymore. And then we select secret detection. And then next up, we want to change all protected branches to default branch. No exceptions. And it finds any vulnerabilities that match all of the following criteria. So we want all of the severity levels, and the status is new with all vulnerability states. Also note that as we make changes here in the UI, our YAML preview will also be updated. So basically, a security policy is another YAML file. And as we make changes here, our YAML file gets automatically updated to reflect those changes we make in the UI. So next up, we want to set up the action. So what should happen if this rule comes into place? Here we want to say we require one approval from individual user. So in our case, let's just add this username here that is provided in the instructions. You can select any other username as well, just for demonstration purposes. I will select Logan. So every time we find a secret in our code that matches the above criteria, Logan will need to approve the merge request before it can get merged. Then make sure that prevent pushing and force pushing is still selected so that we are not blocked later. And also here's some more configurations that you can make, but in our case, we can just leave that as it is. Okay, and then we can click configure with a merge request. All right. So here you can see that actually when we create a new security policy, it creates a new security policy project. So that will happen the first time you create a new security policy. So this project is called Tanuki Racing Telco Workshop Security Policy Project. And all the security policies that you will create under the Tanuki Racing Telco Workshop project will go into this security policy project. And as mentioned before, the policies are just YAML configurations. So that's why we can also treat them like any other code change and create a merge request for them, which then can get reviewed. And you can enforce all of the standard checks to ensure that only correct policies get introduced. So here you can see the policy as code. We can check if everything looks good. And then if we are happy with the change, we can click on merge. All right, so let's take a quick look at this new security policy project, which was automatically created for us. The main part is here, it has a GitLab folder with another folder in it, which is called security policies. And if you go inside, here's our policies file. So this is where all your security policies will go that you create under this project. Now let's head back to our actual project. So let's continue with step 2, where we will look at code owners. Code owners is a file that defines which individuals or teams are responsible for code in a repository. It allows you to specify who needs to review changes to specific files or directories. So in our case, we want to have more control over who can make changes to the README file. And for that, we want to introduce a code owners file. We want to do that in the web IDE. So once we're back in the Telco workshop project, let's go to code repository. And then at the top here, click on edit and web IDE. This will open the web IDE in a new window. Here, we want to create a new file that is called code owners at the root of the repository. So in here, just click on new file and write code owners. And with that, we have our new code owners file. And actually, the instructions already give us a little code snippet that we can add to our code owners file to restrict who can make changes to the README file. Here, please replace your GitLab username with your actual GitLab username, this time with the @ symbol. I will just write my GitLab username here. And with that, we can commit our changes. So to do that, we will go to the source control folder or option here. And then add a commit message, also provided in the instructions file. And then we want to commit this to a new branch. So we go here and say, create new branch and commit. It will automatically create a default or an example branch for us. In our case, we can just leave it as it is and create the branch. And then at the top, okay, at the bottom, it will say create merge request. I can click on. And then we want to uncheck delete source branch when merge request is accepted and click on create merge request. All right, it will load and the pipeline will run. Let's quickly wait for it to load. Can also double check the changes. So here we added a code owners file. Okay. Maybe while this is running through, we can already set it to auto merge and start with the second step, which is actually making a change so we can see the code owners in action. So I will just go ahead and start with that as well. let's go back to the web IDE. In my case, it's still open. Otherwise, you can go to code and then repository and open the web IDE again. I will go back and create a new branch to work on. Make change to README. And then we will open the README file. It should also be in your root folder here. And we will just want to add this one. All right, so just as a test. Okay, we can go back to the README file and then click here. And push this to our new branch. Again, for this, we also want to create a merge request. Here, the pipeline is still running. And then once this can be merged. So back in our merge request for the README file, we can assign ourselves. Again, deselect delete source branch and create the merge request. All right, so we can already see any eligible user can approve the merge request. Additionally, we need approval from Logan, which is optional because we checked that we are still allowed to push. And we also have the code owners file, which is also optional because I made the change and I'm allowed to change the file. All right, so while the pipeline is running here, let's take a look at the results. So how can we now manage the vulnerabilities that were detected by our security scanners? To do that, we will go to Secure and Security Dashboard. This security dashboard is also available on a group level. And right now we are in the project level security dashboard. And here you can track your securities or your vulnerabilities that your security scanners detected over time. So as you can see, until today, we didn't have any visibility in the security posture of our project. And then today we ran the first security scans. And you can see we found a number of critical vulnerabilities, some high vulnerabilities, some medium ones, and some low ones, a few info level vulnerabilities, and a few unknown vulnerabilities. So this shows the vulnerabilities that are present or were detected through scans on the default branch. And it's great for tracking the security posture of your project over time. Another thing I want to show you is the vulnerability report. Again, this is also available on the group level and on the project level. This shows all the vulnerabilities that are present in your project. So it gives you a number of the vulnerabilities and at the bottom also a long list of your vulnerabilities. You can also filter the vulnerabilities as this list might get very long. This can be very handy. So for example, we can say we only want to show vulnerabilities that have a scanner type of, let's say, this SAS scanner. So here now you see all of the vulnerabilities that were found by our SAS scanner. Now let's just click into one of the vulnerability and we will get more information about it. So we can see the severity, the project, the report type, the scanner, the reachable, if it's reachable, the location, and some additional information. From this page, we can also create an issue for that vulnerability if we say we don't want to fix it right now, but we don't want to forget about it, or we can add it to an existing issue. Another thing we can do is change the status of the vulnerability or change the severity. So for example, if we want to change the status, we can set it to confirmed or resolved, or we can also dismiss the vulnerability because we say it's an acceptable risk or a false positive. And doing so will always require a comment so that it's visible for everyone why you are dismissing this vulnerability. Another thing is you can explain or resolve the vulnerability with AI. For now, for SAST, for vulnerabilities detected by our SAST scan, it's possible to explain it with AI, and that's what we are going to try out next. So here you can see it's already generating some information for us. It says it's a missing user instruction vulnerability. It gives us an explanation, also an attack scenario, how this vulnerability can be exploited, and a fix, what can be done to remediate this vulnerability. Lastly, we also see some best practices. So this not only tells you what the vulnerability is, it also helps you in fixing it, and it even helps you in preventing making the same mistakes in the future again and writing more secure code next time. So that's another great GitLab Duo tool. Okay, so lastly, we want to take a look at our issue board again. Since we've made great progress, we can already close some issues. So let's go to Plan, Issue Boards, and take a look at where we stand right now. We have two closed ones, which is set up GitLab CI/CD and planning our work. We can also close securing our application. And we can put planning our release maybe as work in progress, as we will be working on that one next. So that's how our issue board looks now. All right, that's it for the hands-on lab number 3. Again, I will give you 5 minutes to complete any steps that you might still be missing, and I will see you back in 3:47. So see you in 5 minutes. All right, welcome back. I hope you were able to complete the third hands-on lab. Before we move on to our last topic for today, let's have another quick poll. Maybe somebody from the team could pull up the last poll we have prepared for you today. So that's just a quick check-in. How are you feeling about the pace of the workshop so far? Thank you so much for your responses. It's also great feedback. So it looks like for the majority, the pace is just right, which is amazing. For some of you, it's too fast. I will try to slow down a bit. There's also some of you which are lost a bit. So please, if you have any questions, reach out through the Q&A function on Zoom, and we are here to help. But I'm happy to see that so many of you are getting along well. That's great. With that, let's move on to our last topic for today, which is release operations. GitLab is cloud agnostic and has no tie-in to any particular infrastructure provider. It has support for pull-based Kubernetes deployment via our GitLab Kubernetes agent. And additionally, GitLab has a built-in container registry, and with review apps, you can test your application in a production-like environment. GitLab currently has 3 types of registries. The package registry is used to publish and share packages. It supports various package formats such as Maven, NPM, or NuGet. And this list is growing. We have a number of package formats in beta and experimental status. With the container registry, you can use GitLab CI/CD to build your own containers. And lastly, with the model registry, you can store versioned machine learning models. GitLab also has an integrated release capability that allows you to take a snapshot of your project. Additionally, GitLab creates a JSON release evidence file for tracking and audits. Releases can be created through a GitLab pipeline, the releases page, or using the releases API. And you can also create upcoming releases for your customers to reference. Great. So let's get started with the last hands-on section, in which we will cover release operations. Again, let's move to GitLab and go back to the Telco folder and to number 4, which is release operations. So we just have 3 steps in this hands-on section. The first one is preparing for our release. Then we will create a first release. And then lastly, we will plan another second release. So before we start to create our release, we want to grab the image we created in our build. So let's go ahead and grab that image. So to do that, we want to go to deploy and container registry. So deploy and container registry. And then we want to go to the main. And here you can see 2 tags, and we just copy the latest one. So here is a little icon that says copy image path, and that's where we want to click. And this will then be used in our next step when we actually create our release. So to start creating our first release, we're going to use, or we are going to go to deploy releases. So under deploy releases, and then click on create a new release. First, we want to create a new tag. So the tag should be 1.0.0. You can either select a tag from the dropdown or select create new tag. As a release title, we can say initial 1.0.0 release. Like that. We can also add the first release milestone. And then we can select include message from the annotated tag. We also can write some release notes, for example, very first release. And then we're going to attach the release image that we copied earlier. So down here in the URL field, we first want to add HTTPS and then our release image. We also need a link title, which we can call release image. And as a type, we can select image. We can leave the rest of the settings here as it is and then click on create release. Great, so now we actually have our first release. And we can even see that it's 75% complete right now because we have 1 open and 3 closed issues that are part of this milestone. And also the milestone is linked here. We can see the release assets, a link to the release image, an evidence collection, and our release notes. So everything that we need to plan our very first release. So next, we want to plan our upcoming release. To do that, we will go back to releases in the breadcrumb menu at the top. And then click on new release. So that's at the top right. The tag this time should be 1.0.1. Can create a new tag for that. And the release title should be future 1.0.1 release. The milestones we can leave out for now. And then we can set the release date as the end date of our last release. So we can set that to 1 week from now. We can also write a description again. And then we also want to include release assets. This time, we want to include an URL that contains our release events. We have a couple of scheduled release events that we want to include here. So we can copy the URL on the right-hand side under Dive and paste the URL in here. The title can be release events. And you can leave the type as other. And then click on create release. So now you can see that we've created a future release. So it has the label upcoming release. So you can quickly see that it's planned for a future release. It has our assets under other. It has a link to our release events page, and it has some release notes that I added. So if we now go back to releases, we can see both of our releases. We can see our initial release, which is currently ongoing, and we can see our upcoming release, which has a related label. And lastly, we want to take another look at our issue board. To do that, we will go to Plan Issue Boards. And then just move our remaining issue, which is planning our release, to closed as well. So now, refresh, all of our releases should be closed. All of our issues should be closed. And that was it for the last hands-on section. Again, I will give you another 3-4 minutes, let's say until 4, to complete this section as well. And then we'll go back over the last couple of slides. All right, welcome back, everyone. So before we finish up, let's take a quick look at how you can now transfer your project from your workshop environment to your own GitLab account. If you transfer your project into your own GitLab account, you can review the content once the workshop group has been deleted. And you can also finish up anything that you didn't manage to complete today. The transfer instructions can be found under courses, transfer project folder, and there should be a file called transfer, a markdown file where you can find all of the transfer instructions. Please note that if you transfer the project to a namespace that doesn't have an ultimate license, you will lose all of the ultimate features. So that's just something to be aware of. Also, that might be the reason why this workshop environment might look a little bit different on your personal namespace. But as mentioned before, you will have 2 more days to access the workshop project. So let's wrap up and take a look at what we've covered throughout this workshop. First, we took a look at how you can plan and organize your work with GitLab. Then we learned about CI/CD pipelines, templates, and components. And next, we talked about how to secure your application and ensure compliance. And lastly, we covered managing and planning releases with GitLab. All right, so now we have some time left to answer questions. If anything is unclear or you want to know more about a topic, just write your question in the Q&A option in Zoom, and we'll be happy to answer those. I just give it a few minutes for you to have time to write any open questions. So last chance if you have any more questions. I see 2 questions came in about sharing the material. So yes, we will share the material with you after the session. If you have any other questions, feel free to write them in the Q&A now. I see right now we don't have any open questions. So I'll just wait a bit longer before we close out. Okay, let me ask one more time. Please add any questions. we'll just wait. Yeah, maybe 1 more minute, and then we can close if there are no more questions.
Anna, can I come in, please?
Sure, yeah.
Yeah, I just want to ask that or mention that there'll be a short survey at the end of the webinar. It will pop up as soon as this ends. Could you give us feedback on just give us how the workshop went and where you are in your journey and things you'd like to see on the next content? If that'll be very helpful to us as a team to create more valuable content going forward. Thank you.
Thanks, Serafine. Yeah, that's a very valid point. Please provide us feedback. We would be very grateful. And I guess with that, thank you very much for taking part in our workshop. I wish you a great rest of your day, and goodbye.